Right? Let's take a 2 minutes and go over what you all did, right? Right? Make sure you remember this main diagram that explains displacement, velocity, acceleration, right? Right? How you go down again? Right? To go down, you differentiate. And to go up here, integrate. All right? And remember your definitions. Just one thing I want to go to the physics. If you didn't do physics, it might be a little new. Right? There's one thing I want to go through, something called time graphs. Right? There are two types of time graphs that we have to understand, right? Right? There are two types of time graphs that we need to remember and understand. We have a displacement time graph. Let me not use it S, right? If I give you a graph and the graph is displacement versus time, then the gradient of such a graph is what? Displacement times. Gradient is man. I know exam is a few days away. Or 200, 300 days away. Wait, no, it's not 200. Right? No, what's the gradient? Chances are higher. The gradient is velocity. Right? So the gradient of a displacement time graph is all right, it's so small. It's the velocity. Right? So the gradient is velocity R, right? Bigger for the others, right? I don't like that word that's created in here is velocity. My head is really blocked, you know. My head grew up. Right? So the gradient of a displacement time graph is velocity. All right. So what does this line say? Then this line and this line. Line one says what? No, straight line, constant velocity. So this line says the object moving. So if you develop something like this, it means that the object is moving with constant velocity. That's okay. If you have a straight line like this, what does this mean upside down? What does a straight line mean on displacement time graph? You sure? So it's the distance staying the same, but time changing. You're not moving, it's stationary, right? Stationary. And what does 3 represent? So this is what? Moving, stationary. What is this? No acceleration or displacement time graph. And you have a velocity here? Yeah. But would it be positive or negative? Negative. So it means you change direction. So you change direction. Right? Or you can see, let me word it differently. Instead of saying change direction, oh God, I forget all the cards. Oh, yeah. Right. So what we could see here is moving back, right? Moving back to the starting point. Okay? Because it's the displacement and the displacement here is 0. This part shows you change direction and going back to your starting point. So it's like this. You start here, you reach here, and then you take a little rest, and then you're going back to your starting point. Okay? That's what this graph is saying. Okay? You went from here to here, you went from here to here, and then when you reach here, you went back to your starting point. Okay? That's what the graph is saying, right? Right? Even if you saw it before, write it down because most of you all forgot. Right? The only person that don't have to write is Sahara, right? So you remember. Copy it down and let's take a look at. So let's see if we can explain what happening here with the velocity time graph, right? Right, so good. So we need to remember firstly what the gradient here represents. So the gradient of a velocity time graph is acceleration. And the area, unlike that, if you find the area underneath here, right? Area under graph is equal to distance traveled. Right, next week, before I forget, I'll remind you. Next week, Saturday, we are giving questions on differentiation and integration. Right? But the first part of the class, which is summary I said, I'm going to test you on the first part of the summary. Right? On differentiation and integration. Yeah, check in the group with have a summary. All right. That summarizes the whole syllabus for us, right? Right. So what does one say? Constant acceleration. One says constant acceleration. What does two say? Right? Constant velocity, no acceleration, right? Constant velocity, no acceleration. Please remember the formula for acceleration. I think I gave it to you already. Change in velocity and time, right? So if your velocity constant, then this whole value here is 0. Three is what? Right? Deceleration. And 4 is what? 4 is your distance. Well, the area of that, right? How you find the area of that shape again? How many blocks? Right? Half the sum of parallel sides by the height. Yeah, perpendicular height. Half the sum of the parallel side by the perpendicular length or height, right? Okay. So these are some things that we need to remember from physics that we're going to apply today. Today I'm going to give you a look at a full question. Yes, this is and it's physics all, yeah? Yeah. All right. So we're gonna try doing a yeah. Right. Hopefully I get to get talking. I am talking English, papi. All right. Let us take a look at equals. All right, so what's this here? Uh, let us take a look at right. I hope there's a good copy, right? Right, this is 2022 online. Oh yeah. Someone give me a favor now. Tell me how to fix this one. How to make the shared screen larger. Huh? Huh? You could just send it to the document. No one email. Okay, right, great. Everybody should be on the element. Everybody who signed up in the Google form should be on the element as well. Right, that's a good idea. I'll do that. I'll probably use the element best from now on, right? Yeah, well, I made sure they did all yesterday, so you should have gotten it yesterday. Access to advanced and physics. Didn't check. All right, so no, it's on the Moodle. That's the same password that you all have got. All right, you have a little problem here. This paper sideways, so they want to turn, right? They want to turn. Did you fill out the Google form? Yes. And I will listen. All right, grab this one. I want to give you our next thing. That's now. I will listen names there who did not fill it out. All right. So let us take a look at this, right? This is 2023. I don't really like to do these years. Normally I say 23, 24, I pay by paper for cash course, right? Crash course next year, but I will still do it. All right. Take a little read. If you have graph paper, take some graph paper. Otherwise, draw the line in the book, right? Right. To mark paper. Write those things down, and we're gonna put them on the graph. Yeah, I found it. I keep one. I'll keep one. There's one. 5 What? Oh yeah. Write that down, and we're gonna sketch that graph. Oh yeah. Write the info in the back of the graph page, so that's where you're gonna look at, right? Yeah, but yeah. Sorry? Oh yeah, write the info down and we are going to do the graph together, right? Write the info down, quick. Ready? Ready? Right, so we're gonna sketch a graph, right? So a drone tracks the movement of an object in motion on the ground. The following movements are recorded: constant velocity of 4 for 5 seconds. The velocity increases for 3 seconds, and then it moves at that velocity for 7. It slows uniformly until it comes to rest after 4. Right. Can I move this? Right. So after you write it, go to your graph paper. If you do have a graph page, just drop some lines in your notebook. Check any good passage. All right, let's go. I know. Anybody write this up? Let's take a picture fast, huh? Right, so we had a sketch. Ready? All right, so what type of graph are we going to draw? A velocity time graph, right? All right, so let's see if we can take all the info and sketch the graph here. They didn't give us a scale, so we'll have to come up with our own little scale. Online, are they okay, right? Right, on your graph paper, come with a little scale. Crystalline. Sahara. Right, so it's looking like it's going up to 4. And then it's going up to 10, so the largest values are around 10, right? So now let's go with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. All right. Yeah, need that. Huh? Jeremy, you were all right, there you go. Jeremy help out now. What are this? What are this field for underneath? 5 and 3. Try and add up in total. I get 90. So I'm adding with twos. Yeah. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Where am I going to put that now? Right, go and scale. How many done? Pardon me? No. This is an example. If you want to share the graph page in 2, right? You can use that for this one, and next one you can use that in graph page. The 5. Right, set up your scale. If you can do it, go right ahead and catch your graph. If you can't, I have to do it in a few minutes, right? Ready out here? Right, so we're gonna try and sketch this graph. And again, online, if you do have graph paper, just your notebook, right? You don't want to be perfect. Jason, this is 2023. Right, some of the questions I'll be using today, not past people, because you all have access to the answers past people, right? So I have questions a little similar, but a little harder. It'll be in between, like medium. Need now already? It's us. Alright, ready? Let's go. Right. First thing. What's the first thing they said? It moves at a constant velocity of 4 meters per second for 5 seconds. That's the first thing, right? Yeah. Yeah? How am I drawing that? Am I starting from 0? No. Right? You're starting at 4 and then going along for 5 seconds, right? So your graph will start at 4 and for 5 seconds in the middle there. You see that? So you're drawing a straight line. Starting at 4 for 5 seconds. Alright, draw that first. Are you okay with that one line? First part. Alright, you okay with the first part there? Yeah? Alright. Elijah, after white. Elijah, no Baro yesterday. Baro there, nice. Yesterday, see. Must be here. Alright. Next one. What's the name? Next one is what? Next one is the velocity increasing uniformly for 3 seconds to 10. So 3 and 5 is 8, right? 3 and 5 is 8. So what am I doing? Staying straight or going up? Staying horizontal, going up. Going up until I reach, hold on, little line here. I am going up until I reach 10 in 8 seconds. Right, so it looks like that. Pardon me? Again, right. Question says what? Its velocity increases uniformly for 3 seconds. So it was at 5, so 5 plus 3 is 8, it'll stop at 8. To 10 meters per second. So it's moving up to 10 meters per second and it will reach there at 8 seconds. Okay. Right, the whole thing? Yeah. Obviously that's not what you can't miss it there, right? Wait, see. What else? Yeah, got that part, right? Next part is what? It moves at that velocity for 7 seconds. What doing now, Grima? It moves at that velocity for 7 seconds. What to do? Keep the line what? Horizontal. Which means what? Which means keep it horizontal, set it higher up in the sky, set it down. Okay. For 7 seconds, that'll be what? 15? Right up to the ground. 2, 4, 6. 8 and 7 is 15, right?
Yeah.
Where am I? Yeah, I'm too far down. Around there, right? In the middle, right? Hey, somebody get check on the stream working online. You can do it for now outside. Go on YouTube and see. Upside down. It's on now. Let's here again. Upside down. Don't worry, right? Yeah. Do again.
Yes, sir. Yes, sir. Yes, sir.
Right, and the next one. It moves at a velocity. It moves at that. Okay, but not finish that one already. It moves uniformly until it comes to rest after 4 seconds. So what to do? Rest means what? The final velocity is? Final velocity is 0. So it's going all the way down in 4 seconds, right? So 4 and 15 is 19. The graph looks like that. Yeah? Online? Right? Asia, see the graph went all the way down, right? Yeah. Online are located, Elena, Barrow, Sebastian. You're located. So your graph looks like that. Right? Check the graph, fix it from up. Take it out more to find, right? Right? I don't want to move from this page, so I'll call out what is next, right? Oh gosh, I love like one line. Okay, that's one line. Right, part 2. Calculate the distance traveled. Part 2. Part 2. Part 2. Calculate the distance traveled. Right? People who did it in the book, they'll be right? Calculate the distance traveled. How we do that, guys? How we find the distance traveled there? Area under the graph, right? Yeah. Well, I think so. Are we going to a street right? Right. So how we find how we gonna find area there? Now we do not all yet because that is not a regular shape, right? Right, cut it up. Right, cut it up. You have different options, cut it up, right? If you want, you can split up here. Trapezium on top, triangle and rectangle, it's up to you. Right? Or as Kai said at the beginning, somebody said at the beginning of the class, count the blocks. Yeah, well, can't count the blocks, so that work is out. Right? So if you want, you could right, split it up, find the area, come on. Split it up and find the area. Take your time, and I'll help you.
Like that.
Now get the area.
Yes.
Right, so we have a rectangle, we have a rectangle, trapezium. I start starting here, let's find the area here. I would say what, 5 by 4? Yes, 5 by 4. So that's 20 meters. Here's half base by height. The base is what? 1, 2, 3, 4. And the height is 10. That's 20 again. And this larger trapezium here. Half the sum of the parallel sides. How about that olive? Go some blue line to blue line again. 5 to 15, 10. Half the sum of the parallel sides, right? By height. Sorry. I read it so far. Right. So underneath here is what? Underneath here is 10 by 4, which is 40. Any answers online? Did you get better answer? Any answers online? You can mention your final answer. And how much you got here? Half base by height. Right, I will call that. So it's 20, 40, 20. Two parallel sides are what? 10 plus 7. And the height is right, so that's 17 by 3 guys. 51. So the total is what? So the total is 80 plus 51, which is 151. Who's that? One second. All right, 131. Good job, Baru. Good job, Sebastian. Right, I broke it up into 4 shapes, right? Because that middle shape was not easier. Yeah. You can make it up into 5. And then triangle and a rectangle. Yeah. Copy it down, fix it up. Any questions online? All I did is break it up into 4 parts and find its total area, right? Sahara, Samir, are you okay with that? Half is some of the parallel side. The parallel side is here, which is 10, and here 7. And the height. Why you do that? Yeah. Yeah, what? Yeah, we do a master study. See how it's looking. Yeah, I want to see how to use that. And I feel like kind of use it. Switch. Yeah. I will see that. But I get characters like I really like Jeremy. Who's your character? Jeremy and you all right, ready? We have one more part. The last part is determine the acceleration in the final part of the journey. Determine the acceleration in the final part of the journey.
One sentence. One day. They have a current here. Let's go out there, right?
But it's with one that you are putting on.
Yeah, and it's 1 cent. One bit is 1 cent. If you got it, that already.
Oh, so where they get money from?
Yeah, it's pretty funny.
Yeah, pretty much.
Decent buddy.
I thought it was
US. You multiply now myself.
yeah, but that's what you're going to people have the same for long now.
Spring
I
think so. Yeah.
Okay. Are you ready? Right, so find the acceleration during the final part. In the final part, so that's this part coming down here. Right, the final part is here. How are you doing that? The final part is from here to here.
Alright, so
V over T no.
you might still get.
Just find gradient.
Or the gradient.
Just find gradient. If you want, you could use final velocity minus initial on time. But technically the gradient is the one to use. But the same value. Right? So if you want, you can use the initial velocity and final velocity and time.
But if I want to I want to avoid so yeah promote that most to the government yeah I talk more about also never here yes go words
Ready? Right? And the value is what? Positive or negative? Negative, right? So if you work it out, the acceleration is you can use gradient, you'll get the same value. I will use gradient, right? So I am using the y value as 10 and the x value as 15, y value as 0, x value as 19. Correct?
Yeah.
Right? So that's 10 over minus 4, which is minus 2.5.
yes
Minus 2.5 meters per second. Right? Minus 2.5 meters per second. Right? Don't forget to put the minus sign in front, right? Sahara, check back yours there. Right? The next way to work it out is 10 minus 0 over 4. 10 here is 4, and yeah, 4 seconds, the last one. You're okay with that? So sometimes you get a physics session in advance, right? Sometimes it's easy like this, sometimes a little more challenging, right? But I can find the older one that's more challenging. Anybody writing online? You write it? Oh, yeah.
that's correct yes
I'm out. Can I take this off?
yes
Yeah. All right, nice. Let's try the next one. You want to do that here? Or the Liverpool All right, next one. Anybody ever read this copy on 2022 or 2021?
I can find us.
My copy of kind of upside down. Hold on, I'll try. All right, let's see if you can see this one here, right? Let's try this. Remember, average speed is what? Did I give it a formula last week? Average speed. Check out if I give you average speed. No, I didn't give it. I'm sorry. Right? Average speed and average velocity. In the summary though. Right? Average speed is total distance traveled over total time. Average speed is total distance traveled over total time. Average velocity is total displacement over total time taken. Average speed, total distance over total time. Average velocity, total displacement over time. All right, take a little read there. I don't know why this thing's still here. Time. Try this one, please. And this is 2021. Take your time, right? This one a little bit different. They didn't give it from a graph. So here what happened here. A motorist starts from a point X and travels 60 meters due north, right? 60 meters due north to a point Y at constant speed of 4. Right? He stays at Y for 25 seconds and then travel at a constant speed for 10 for 100 meters to south to point C. So if you want, you can try to put it into a graph, Nathan. Right? So you can try to put it into a graph, or you could write the encoder and see if you can get total distance and total time from it. Right? I would, in this case, I wouldn't draw a graph, right? What I'll do is I'll try to write down the encoder go along. Right? So you're leaving X and you're going to a point Y, 60 meters due north at a constant speed. Right? So see if you can put the input together and then find total distance and total time. Okay, when you have a few minutes, try it quick, try it quick. Right, now let's making sure you're doing it. Okay, we're doing it. Right, so X to Y, 60 meters, 4 meters per second. So can we find time? Yeah. So remember, speed is distance on time. Right, so time is distance on speed. That'll be 60 over 4. That's 15 seconds, right? So X to Y is 15 seconds. He stays at Y for the next 25. Right, so X to Y is 60 meters, 15 seconds. Then at Y, he there for the next 25 seconds. And then travels at a constant speed 100. Right, for 100 meters to south to Z. Right, so that's 100 meters. And his speed is 10. So again, we can divide 100 by 10, and we'll get 10. seconds, right? You okay with that? Yes. So all I did is I found this total distance and total time and everything that we needed. You see that? So how we get average speed remark? Total distance. It has to be total. So tell me what the total distance is. Yeah, total distance is what? No, 60 plus 100. Total. And what's the total time taken? Yeah, add up all, right? 15 plus 25 plus 10. Okay, you're adding up all the time and you're adding up all, right? And we got 3.2. Right? 3.2 meters per second. Right? So you break it up part by part, we broke it up part by part, and we work it out, right? Right? You have one more part after that. They ask for average velocity after. Try that, please. A little bit trickier. It's a little bit trickier. Find the average velocity. Right, whoever doing exams with us, any subject, please remember to drop in your form. Okay? Online as well. If you're doing anything with us.
Only chat. Everybody saw it.
Who doing subject with us?
Before the end of next.
Wait, wait.
Before the end of next.
Before the end of next week, right?
Only chat did that, like
Okay.
Saturday did that.
Right, now we need to get average velocity, right? So we know the total time in this whole thing, that's not the problem. The problem is the displacement. So let's take a look at this here. You start at X, then you go up to Y. Y is 60 meters away. And then you go down to Z. Right? You go down to Z, which is 100 meters lower. So what is your total displacement? Huh? Your total displacement is how much? How much meters? 40 meters. Ideally, only that should be negative 40, right? Ideally, because it below the starting point. Right? So therefore, your average velocity will be minus 40 over 50. Time was how much? 50. Always see that rest is total time, right? So I have minus 0.8 meters per second. Right? Okay? So that is your average velocity. Sorry? Go over that again now. Now, right, so you start at X and you go up 60 meters. Jeremy, I'm going to do. Would you like to go to for you? Alright. So you're starting at X and you're going up to Y 60 meters away. You okay with that? And then when you're at Y, you're coming back down to Z. Z is south, right? And you're coming back down 100, right? So you're coming back down 40 meters below your starting point. Once you're below your starting point, is minus 40. And the total time as well, 400 meters. Right? Total time that is saved. Right? All right, let's squeeze in one more. Somebody. Right? Nice. Right. Have some good news for you. No more graphs. We're doing what we did last week. Come on, do this fast. So for homework, remember differentiation and integration next week. All right? We're doing a whole revision class on that next week. Just questions only. So make sure and do revision. That's normal, right? That's normal. Guys, do this please. Hurry up. Here's what we did last week. Right? How did we go from acceleration to velocity? Integrate, right? Go ahead, have fun. Just fast. Oh yeah, well done in that sound. Come on, hurry. That's the last one here. Today, I'm going to buy any board. We're playing that is. We're playing hurry up, do that please. Last one, last push-up. Last question, I'll be done. This is the all the names who are not on the LMS but in the group, right? Sharana. Karana, the LMS, Sanjay, the LMS, Rihanna, Jeremy, Everett, Baru, and Adrian. You're not there because you didn't fill out the Google form. Alright, so I'm going to make us send back the right, I'm going to send it back, and only the people who not on the LMS will be able to fill back out the form, right? Do not fill out the old form, fill out the new form I'm going to send. Okay? You have to be on it because that's where everything, all the edited videos, all the notes and all the filters are going to put right in. Right? So I'm talking to the parents are using the output from that. Yeah, and one of them we call it parent. We are not doing any work. Yeah, come and say.
Next
Alright, so yeah, quick volume. How we getting velocity again? Integrating acceleration. So when you integrate t squared, you will get t cube on 3. Give it to miss in the office. Plus c. We have a slight problem. How we getting rid of c? It starts at rest, right? So what does at rest mean? At rest means that when t is 0, b is 0. So therefore, when you work it out, you'll get c at 0. So the equation is 1/3 t cube plus 0. I can leave out that. Right? 1/3 t cube is the answer. Calculate the displacement. How you get the displacement, Sanchez? Integrate which one? Right. So I have a question here earlier. Do I have to find plus CSEC? Do I have to find plus C? No. All I have to do is use the limits. Right? Plug in 2 and 0. Alright? Plug in 2 and 0 and you're done. We're gonna pass the more again. Right, but those are the names who not put in fill out the form. I am not only elements, right? I didn't have these well, he didn't get an email or something. Just make sure you do it, please. Oh yeah, Paul, then do this last one. Have we done? Integrate, start plug in the values. Caleb. Caleb. Come on, integrate past last part. Idea we come to the oh yeah, work it out and plug in your values. Do you have to leave the 1/3 there, Nathan? Or you can do the 1/3. Right, if you want, you can bring the 1/3 outside, right?
Oh, let's see. I do.
I have to wait another three months answer and then we can move on first. Ashley. Until that. Right, what we got here? So that'll be 1/3 between 2 and 0. Right, so I'm bringing out the 4, so that's 112. 112 by 234. That is 16 and 12. What is that again? 4 and 3. 1.33. Anybody get that?
Yeah, I do.
Yes?
Yeah.
1.33. Yeah? Alright, nice. Right, good job.